Hi, it's Karen with Mini Math Lessons, and this is a second activity that goes along with Dilation Explorations number 1. So this is Dilation Explorations number 2. The link to the activity is below in the description, and all you have to do is post the link into your browser and the activity will come up. So again, this is a continuation or a second part. So it's assumed students have either done the first activity or already have a pretty good understanding of what a dilation does, meaning they understand that the point of dilation is where the new image is moving towards, and the scale factor determines how big or small the new image is, the dilated image is, that corresponding sides have a proportional relationship, the same proportion between all the sides, and the ratio is equivalent to the scale factor. So all of this is assumed that they know. So now we're just kind of exploring some interesting applications of dilation, and it's more of kind of just a fun, wow, I didn't know it could do that. So the first part of this second exploration is we're going to be looking at dilations in a coordinate plane, and specifically dilations that have a point of dilation that's at the origin. What are some interesting things we can discover about the coordinates of the vertices? So remember, they've already got this understanding that corresponding sides have the same proportion, have the same ratio, are in proportion to each other, and it matches this scale. So that one we already know. But now we're going to look at coordinates. And so if you notice, I have the coordinates of corresponding points here. And obviously they're different, and here's the scale factor, but is there a relationship between the x coordinates of corresponding points and the y coordinates? Does that also have an impact? And could we use this understanding to construct the dilated image of a pre-image if all we know is that it's been dilated with the point of dilation at the origin? So that's what they're going to explore in this first activity. So it's really a matter of using the calculator, and are we seeing a relationship? So what is and I'm just going to take the x coordinate of the A that is currently there and set the ratio to the x coordinate of its corresponding point. And what they're going to discover if they're doing this, and they can check all of all of the different ratios, and hopefully they're going to figure out that it is the same as the scale factor. Now, this happens to be in standard form. I could just click here and see the decimal version and notice that it's the same as the scale. So then they can just explore that, move things around, change the scale. The question has them, look at a negative value for the scale, and does that still hold true? And look at a larger value and a smaller value. And basically, once they've tested out a bunch of things, come up with a summary, a summarization of what happens to the coordinates of vertices, corresponding vertices. Okay, so that's the first activity. And let me move down here. So then the next one is, here's an application of dilations. When do we ever use dilations? So this is a scale. We talk about how scale models are dilated image of the original object. And so this is an example of a scale drawing of an apartment. So obviously the real apartment is much bigger than this. And so we kind of give them the scale. We tell them that the small grid represents 0.5 feet. So each little block is 0.5 feet or 6 inches, which represents this ratio right here. 6 inches in the dilated image, that's this, is equivalent to 12 inches in the real apartment. So then, how could you use this understanding of dilation and scale to figure out what the real dimensions are of the living room and the bedroom? And they could obviously explore more, but it's really just an application, and how do people actually use dilations to help them in the real world? So architects use it, animation uses it. So that's sort of the exploration here. You could throw in a map, and maps use it, right? So that's what we're doing here, just kind of exploring an application of a dilation and scale. Then we're going to go explore a little bit more about what perspective drawing is, which is really just dilations, and it's making you perceive an object as bigger or smaller based on how much has been dilated. So I have an image here of a road, and I drew And so if you notice, the point of dilation is here in this blue one, and I've used my lines that connect the vertices, the corresponding vertices. So this was done in Exploration 1. And the dilation image, which is the green one, is right now smaller than its original image. And we're going to start exploring, like, how does dilation help you have a different perspective about an image. Now, this is a house technically, and depending where I put it, it makes it look like it's closer and further away on this road or driveway. So they're going to just explore. And this is just for fun, but kind of understanding how dilations are used in things like art and images and photographs to help us perceive something as being close, big, small, those types of things. So they have a slider that controls it. So if I just move the slide, let's move the slider to 1, which remember they've already explored this. It should land right on top of the original image. And if I make it larger, the scale larger than 1, my green dilation is larger than the original. So they can explore that. So now what happens if I get rid of that original? So we're going to click this hide show button, and notice it hides everything. So now in theory, this house looks like it's right at the top of the road. And what would it look like if we moved it, closer to where that point was? It looks now like I have a house at the end of the road. So this is the driveway to the house. So again, this is just an exploration of how dilations are used to give us a different perspective of things, to change the size, a dilation by a certain scale to give us a different perception of an object in art or on a picture, things like that. So that's all this is an exploration of that. So let me get this back. So have fun. This is kind of just applications of dilations, trying to help students understand where dilations are actually used.